Okay, in this section 5-8, we are looking at the ambiguous case of the law of sines. Okay, so it turns out if you are given this pattern where you have two sides and the non-included angle, if you're given those measurements, okay, there is a possibility, depending on what those measurements are, that you could have two different triangles with those measurements for those three parts. Okay, and so if that's the case, then you've got to know that there are two possible angles here for this angle that we're going to be getting ready to look at that would actually yield two sides and angles of the measurements that are given. All right, so that's kind of what we're going to talk about in this section, and it's important to kind of know when there's a possibility that there could be two triangles with those measurements. All right, so here's the deal. Let's say you've got a triangle and you're given sides A and B and you're given angle A. So remember, angle A is across from side A. Okay, and so when you're given this pattern, two sides and the non-included angle, side angle, all right, then what we can do is we can take a look at these measurements as well as the value or the measurement for H, and H is going to be, okay, so take a look at these drawings here. H is going to be the altitude, right? The altitude that comes down from the vertex where side A and side B connect. Okay, so again, H is the altitude that comes down from the vertex where side B and side A connect. All right, so that's what H is. Okay, so now when you guys are looking at this, and notice right here that H is going to be equal to B times the sine of A, because the position of where H is, right? The position of where H is, then the sine of A is opposite over the hypotenuse. Remember, if this is an altitude, that'll be a 90-degree angle there. And so since that's the case, H is the opposite and B is the hypotenuse. So sine of A equals to H over B. Well, if you multiply both sides by B, then you get H equals to B times the sine of A. So that's where that equation comes from, and that's how you calculate the altitude, the value of H. So what we need in order to do this comparison from this chart is we need the values of A, we need the value of B, and we need the value of H, which can be calculated from here. Okay, now here's kind of an overview of all the scenarios. First of all, you've got to look at your angle that's involved, angle A. If angle A is acute, then there are four different scenarios that we can use to get three different outcomes. Okay, so the first scenario is that A is less than H. Well, if side A is less than H, then there is no triangle that can be formed in that case. Okay, so if you're given A has a length of 8, and then you calculate H from the other two values, and it's, say it has a length of 10 or 12, if the H is greater than the A, then this is not going to be long enough to close and form a triangle. So in that case, you would say there is no triangle that can be formed with those measurements. That would be your answer. Okay, so let's say A is still acute, but A equals H. They're the same. All right, so when you notice that the values are the same. If that's the case, then there's just one triangle that can be formed with those measurements, so you can proceed and find all the rest of the angles in that triangle, because there's only one that can be formed. Okay, let's say that side A is greater than side B. So side A is greater than side B. In that case, there is still only one triangle that can be formed with those measurements, so you would proceed, find your answer, and all your answers would be valid. Okay? However, this is the case that we need to be made aware of. So in this case, where A, the value of A, is between H and B, when A is between H and B, in other words, it's longer than H, but it's less than B, if that's the case, when you get those values and analyze them, then there are two triangles that can be formed with the given two side values and angle value. In other words, remember, they're going to be giving you angle A, they're going to be giving you side A and side B. They're going to be giving you those three things. However, when you calculate H, if side A is between H and B, then there are two triangles that can be formed with those three measurements. Okay? So the first one would be if the side A is here, right? But since it's between these two, side A can then swing over here, and then there's another place where it can create a triangle with that same measurement. So this triangle can be formed with those three measurements for angle A, side A, and side B. Okay? Or this triangle can be formed with those measurements, those given measurements for angle A, and side B. Okay? So since that's the case, if you were given those three and the question would say solve the rest of the triangle, then whatever you got for angle B, just remember that there would be two valid answers for angle B that would create a triangle. So you just got to remember that there's not just one answer that would work to create a triangle that would fit those measurements for angle B. There are two measures, and I'm going to show you how to get both of those measurements when we get to that type of problem. Okay, so this scenario is really the only one that you have to be concerned about as far as making sure you get two different answers for that angle B, so that both of them would be, so you take care of all cases, because there's two triangles that can be formed. Now, if A is obtuse, you don't have to worry about two triangles being formed. You just have to know if A is less than or equal to B, then there is no triangle that can be formed. So you wouldn't be able to plug it into the law of sines and get an answer. Does that make sense? So really, and then also if A is obtuse and side A is greater than side B, then there's just one triangle that can be formed. Okay, so in any scenario where one triangle can be formed, you do law of sines like normal, get your answer, that one answer is correct. Okay, what you've got to be concerned about is the two cases where no triangle can be formed, right? Because in that case there's no answer, right? Or the case where two triangles can be formed, in which case there are two possible answers for angle B that would satisfy the problem. All right? So, for most of these, we're not going to ask you to actually go through and solve all of them, because we've already done a section on the law of sines. But what we are going to do is we're going to ask how many triangles can be formed with this scenario. Okay, so the first thing you need to look at is your given measurements, and then ask yourself, okay, do I have a side-side angle pattern? And in this case, yes, I do. I've got two sides in the non-included angle. And so the next thing that you want to do is you want to calculate H. So remember, H is equal to, in this case, it's going to be 12, because the 12 is the B. Remember, I'm using this equation right here, times the sine of angle A, which is 42. And so now, if you plug that into your calculator, then you would see that H is equal to 8.03. All right, so now let's go up to our chart, now that we have the value of H, and let's go through and see, okay, how many triangles can be formed with the given measurement. So my answer will either be none, 1, or 2, based on the length. So let's go through and find it now. Okay, so now, first thing you want to do is look at your angle. It's 42, so it's acute. So these two are out. I'm not going to test those two. Okay, so what I need to do is I need to take a look now at, see if it's this scenario with A and H. Okay, so is A less than H? Is A less than H? Nope, the first one's out. Is A equal to H? No, the second one is out. Is B greater than or equal, or excuse me, is A greater than or equal to B? Is A greater than or equal to B? The answer is yes. And just double check the last one. Is A between A and B? No. So this is the scenario that works, the third one. And so how many triangles can be formed with the given measurements? There's one triangle that can be formed with the given measurements. Okay? And then to finish it, you can go and proceed it. If it asks you to actually find the rest of the values in the triangle, you could use the law of sines just like you normally would to find all three of the missing parts, and you could know that all three of those solutions are valid because there's only one triangle that can have these measurements. Does that make sense? Okay, so like I say, we're not going to go through and find the three values because I want you to have some more practice in finding how many triangles can be formed. All right, so what about this next one then? So I've got A, I've got B, and then I've got A. So as long as you've got the angle that's across from one of these sides, you know you have the side-side angle set up, non-included angle. So again, my first step is to go in and find H. So in this case, remember H is going to be B, which is 25, times the sine of A, which is 85. All right, so the value of B of A right here in this case, or the value of H is going to be, when you multiply that out, it'll be 24.9. Okay, and so now we can go back and look at our setup. And so again, 85, so 85 is still acute. And so again, I'm looking at the first four setups, so you got to check your angle first. And so on this one, the first scenario is A less than H. In this case, 15 is less than 24. So 15 is less than 24. And so since that's the case, there are no, how many triangles are there that could be formed with the given measurements? The answer in this case is none. Why? Because A is greater than H. Is A equal to H? No. Is A greater than or equal to B? No. A is not greater than or equal to B. Is A between H and B? No. So the only scenario that fits is the first one, indicating that there is no triangle that can be formed with these measurements. So again, if you go through and you say, okay, I'm given these, let me just go with this, and it says find the other values of the triangle, the other three parts of the triangle. If you just go into law and science, you'll plug in and you'll get an answer. But remember, it's all an irrelevant point because there is no triangle that can be formed with these three measurements. That's what we're saying, and that's the purpose of having to check first. So anytime you have side-side angle, and they're asking you about the triangles, the sides and the angles, okay, you've got to make sure that you go in and you check this first to see if a triangle can even be formed or not. You see what I mean? Because you might go through it, find all the missing parts and the missing angles and say, here's their measurements. You'll get an answer when you plug it into the law of sines. Okay? But, like I say, it's all irrelevant point anyway because there is no triangle that can have these measurements. Okay, so that's what we need to understand. Okay, so the next one. Let's take a look. Okay, first of all, let's find the value of H, just like we typically would. All right, so H is equal to, in this case, 31, which is B, times the sine of 20.5. Verify that you do have side-side angles, so we know we need to check that first. My H here is going to be 10.86. And so now, again, this is an acute angle, right? So we've got an acute angle here that we're looking at. And so let's see if we can test. So I need to try to look for A, and I need to look for H. Is A less than H? So is A less than H? The answer is no. Is A equal to H? No. Is A greater than or equal to B? No. Is A between H and B? Is A between H and B? The answer is yes in this case. So how many triangles are there that can be formed with these measurements? There are 2 triangles that can be formed with these measurements. And so once again, this is the scenario that we have here. So again, my A, my angle A, my side A, and my side B, those measurements will all be the same, right? But the parts that will change here, okay, will be angle B, right? Angle B can change. And then, of course, angle C can change, right? And side C can even change. Okay, so that's kind of what you've got to be aware of here. And so if you went in and you solved them, like for example, let me show you how angle B can be 2 different things. Okay, so if I were to go to solve this now for angle B, I could write the sine of B over 31 equals to the sine of 20.5 over 12. All right, so if I went in and put it into the law of sines, it'd look like this. And then we get 12 times the sine of b equals to 31 times the sine of 20.5. Then you'd have to, what else? Divide both sides by 12. Divide both sides by 12. And then we'll get the sine of b is equal to, that's 0.9047. Then we can do inverse sine of both sides. Inverse sine of the sine of b equals to the inverse sine of 0.9047. And then we'll get angle B. Now, if you actually plug that into your calculator and come up with the answer here, you would get 64.78. Okay. However, that's not the only angle for angle B. Okay. So that's the acute angle, but there's also an obtuse angle B that would also work. And so to figure that out, remember this is isosceles, so if this is 64, this is 64. So if I wanted this angle, the other angle that would work, I'd have to do 180 minus 64.78. And 180 minus 64.78 is 115.28. Okay, which is also a value that would work. As a matter of fact, if you put this value back up in here and then put this angle back up in here at the beginning of the fraction, you would see these two values are equal to each other. All right, so that's kind of what we're saying when we have two triangles that are formed. There are several parts that would have more than one correct answer based on their position. So like I say, when you've got this scenario, there are two angle B's that would work. Okay, there are two angle C's that would work, this one and this one, and then there are two side C's that would work, right? And so that's why it's kind of called the ambiguous case, because you can't just plug it in one time and think that you've got the answer, all right? So that's kind of what we're looking at there. But for purposes of this, I just would be asking you in an ambiguous case how many triangles could be formed, not to go through and find all the different possible pieces, right? Because that would just be extremely long problem for just one triangle, and you still have a lot of ifs then anyway, because it's not set, because there's two different sets of answers, in other words, that you could find. All right, what about the last one though? Okay, so how do we handle this one? This time we don't have A, B's, and C's to look at. We've got angle R, side T, and side R. Well, we still have side angle, because angle R is across from side R. So it still works out. And so when we go through and look at this, if you wanted to go through and calculate the H part of this, then we could. And so to calculate the H part of this, then this would be what? H equals. Now, what's the B part here? Remember, this is the A and this is the A, so there's the B. So that'd be 29 times the sine of 153. So when you go and plug this in and take a look at this, okay, so really calculating the H here, I'm going to erase this and let me show you why. Okay? Take a look at the angle here. It's 153. Well, remember, that's an obtuse angle. So when you go in and look at these, the two numbers that you're comparing are A and B. Okay, there is no H to compare when you've got an obtuse angle, so there's no need to go in and find the H. And plus that angle, there's more than 90 anyway. So when we go and look, anytime you've got an obtuse one, like in this case, just go in and compare. There's no H. You already have the A. This is the A, and this is the B to look at. The A will match the angle that you have. And so when we're going through and we're looking at this, so what were my two numbers again? So my A is 16, my B is 29. So if my A is 16 less than 29? Yes, it is. And so what that means is there is no triangle that can be formed with these measurements. Okay? So like I say in this section, the key is to use this chart to be able to tell how many possible triangles can be formed with those measurements. Okay?